This is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. In the previous lecture, we have seen the definition of an algorithm and the definition of an analysis. So, what is an algorithm? It is a finite set of steps to solve a particular problem. It is called an algorithm. An analysis, it is a process of comparing two algorithms with respect to time and space complexity. So, here we have two things, that is time complexity and space complexity. Now, we do analysis in two ways, either priority or posterior analysis. Priori analysis means that is before execution, and posterior means analysis after execution. So, whenever we do analysis before execution, then it is independent. Whenever we do analysis, then it is independent of a particular hardware. Let's say if I write here main and I have int a comma b. So we are going to write a simple algorithm int a comma b, and let's say I had to scanf here the values of a and b, then I have to print the value of sum. So I have to print the value of sum. I have written simple values here, that is the number of lines. Now whenever we are executing this program, now in executing it, definitely it will take some time. Now when you execute it, then after executing means is this posterior analysis. So you got the output, but you got time, let's say it is 0.4 seconds. So whenever there will be a posterior analysis, it will give you a fixed amount of time, and that time is 0.4 seconds. But if I change this whole program, let's say if I change my hardware, let us take from Pentium 4 to i3 or i7 processor. So this time it will be 0.3, 0.2, 0.1, means it will be decreasing. So whenever you do posterior analysis here, it means that it is dependent on a particular hardware. What we are talking about in the prior, it is just finding the number of iterations, that is how many times each instruction has been executed, how much it is frequently executed, what is its magnitude, how many times the function is calling itself. We calculate it like this. Like if we talk about this, I did not convert it into a program. Instead of posterior, if I do it in priori analysis, then I am writing here read A. So it will take a constant amount of time. Let's say how many times it will be executed. Instead of time, if you calculate how many times it will be executed, that is the iteration. So obviously it will be executed only once. How many times will it be? 1. Sum 1. So finally the output of this, the time complexity of the above program would be 4. No need to put seconds or milliseconds. You are just calculating iterations. If we talk about any factorial, let's say factorial of 1. Now factorial is recursion based. So factorial will call in this way, n minus 1, n minus 2, n minus 3, so on. So how many times the function is calling itself, you have to write that count. So whenever we do prior analysis, it means it gives an approximate value. And whenever we do posterior, it gives an exact value. But what do we have to go on? One approximate or prior value. What is this region? Because it is independent. There is no dependency on hardware. What I have here is dependency. So remember, and due to the dependency, uniform value will not come. Because if you have a good hardware, always the different values will come. If you run this program on supercomputer, then it will be 0.001 second. So that means whenever I do good hardware, my time will keep changing. So now there is uniform value. This uniform value is enough, but it contains always the uniform value. What we will do in this, let's say I take out the worst case in this. How much answer is coming in the worst to worst case? How much coming in the best case? And it will be approximate value. And whenever we represent it, I have asymptotic notations. Asymptotic notations are nothing but it is a mathematical way of representing the time complexity. In prior analysis, what we do is we have done the analysis without execution of the algorithm, and now if you want to calculate time without execution, then what we do is how many times a statement is executed, or that is called the iteration or the frequency, and we can say the number of times a function is calling itself. So what we are doing here is to represent the number of times. We are just representing the number of times, and to note that we see some notations that this algorithm has this much time complexity, the other algorithm has this much time complexity, so that we can compare both of them and find out which one is better algorithm. This is what we will do it in analysis.